I'm Ashton Addison from RChain for Investmentpitch Media and the Crypto Coin Show. And today on Blockchain Interviews, we have Greg Meredith, the president of RChain Co-op. Greg, welcome back to the show, and it's great to have you here again.
Oh, yeah, thanks so much for having us. It's always a good time to chat with you.
Definitely. I'm really excited for our conversation. I know RChain has had a lot of updates this year, and there's lots to talk about. For the people that haven't seen our previous interviews, I'd love if you could just kick it off with an overview of what is the RChain network and blockchain, and what makes the project unique.
So RChain, effectively now we can show that it's the most scalable blockchain. And we'll get into that as we talk about the features that are coming up. But one of the things we posted quite recently was a demo of how the chain scales up as you add nodes.
Mm-hmm. Yeah, it's been a major issue in the industry, obviously, for many, many years now. So obviously that's a huge problem to be tackling.
Yeah. So, essentially scaling comes down to if you add hardware, you get more performance. Right. Mm-hmm. And so and for most blockchains, if you add hardware, you get less performance. So RChain is architected in such a way that whether you add hardware to a single node, right? So you make a single node beefier in terms of more compute, more memory, mm-hmm. that kind of thing. It will be able to take advantage of that. And specifically, if you add more cores. So you get more concurrency, it can take advantage of that. But then also if you add more nodes, the network can take advantage of that. So we get scaling inside a shard by adding hardware that way. And then we get scaling across shards because as you're adding shards, you get more capability that way. Mm-hmm. So, yeah.
That's interesting. And the traditional, some have argued that there's a traditional trade-off between scalability and decentralization, and when you add more nodes, the more nodes that you have, more people have to verify that, or more nodes have to verify, and then it sort of slows it down. But I'm guessing that's not the case with RChain.
That's not the case. I mean, we don't get perfectly linear scale up, right? So there's always a little bit of cost every time you add, but it's sublinear, and it's the delta between exactly linear and where we are is enough that there's a big long range of curve that you can have of improvement before you start to see diminishing returns.
Mm-hmm. So, yeah. And I know it doesn't come easy, on day one to have the most scalable blockchain. You've been working on this for years, but I have seen that you are in one of the next phases of what's called the next finalized state, or the last finalized state, which is now in the testnet of RChain. Can you talk about what is the last finalized state functionality? How does it benefit the scalability, and where are you at with that right now?
Yeah, so one of the most important things about our consensus protocol is that it has finalization, which means that at a certain point you can say, we don't have to remember everything prior to this state. Mm-hmm. We can forget it. Which is unlike Bitcoin, where you have to always go back all the way to the Genesis block. Mm-hmm. One of our members says, "Oh, it means RChain can poop." What validators can do is they can compact their state. So at a certain point, you can prove that all of the different arcs of the DAG have to come through a particular state. Mm-hmm. They can't avoid that state, and so everything that's prior to that state can be forgotten. Mm-hmm. Which means, and so the practical upshot is that it means that when you're syncing to the network, mm-hmm. you don't have to go all the way back to the dawn of time, which mm-hmm. keeps taking longer and longer and longer the longer the network is in operation, right? So for us, what we've shown recently is that it takes about 2.5 hours to sync with the network, and that will improve and improve and improve.
Mm-hmm. That's very interesting because, with Bitcoin, there aren't very many people that are now running nodes. I think I just saw the stat today was 0.0001% of people, maybe even less, that are actually running their own full nodes to help verify, because it seems the blockchain is becoming terabytes and terabytes, and you can't even fit it on a normal computer anymore. So with RChain, you don't need to have previous transactions past a certain point, but does that mean that
point
those
keeps advancing, right? As you
Yeah.
get more on the chain, then you'll get to states that everyone has to come through, and so you can forget all the prior to that, and so on and so forth. Right? So it's a sliding window of stuff that you have to sync to.
But does that mean that the transactions in the so-called Genesis block are forgotten, or they are still somewhere, but the nodes, the people that actually are helping verify the network, don't need to have that localized on their computer?
They don't have to have that localized on the computer, and we see that as a whole aftermarket kind of thing. So people who really want to have audits that go all the way back to the dawn of time, they can do the warehousing, the data warehousing that provides that kind of service. But for the network at large, you don't need the service anymore. All right, you don't need those transactions. That service is sort of an aftermarket thing. So many people can offer that, and they can provide either centralized or decentralized solutions. Yeah.
And so now that really helps with enabling more people to help verify transactions on the network. But does it also help with people that aren't necessarily running a full node, but they're sending RChain transactions, and does it just make it faster, or are there other benefits to people that are just using the network?
So it makes it faster in a lot of different ways. So, but mostly what it does is it makes it more robust. What it means is that you can add more nodes with lower cost, and basically what you want is as many nodes verifying as possible, right? That's the more nodes you have, the more security you have in the network. So that's the idea. And as you said, if you have to go all the way back to the dawn of time, then that just gets bigger and bigger and bigger and bigger. And so the total number of nodes that can be verifying transactions continues to shrink, right? Because it takes too many resources for the ordinary person. So it's mostly about sync time and network security.
Definitely. And you mentioned that this is now on the testnet. What are the next steps involved with finalized state and getting it into the mainnet live on the network?
Basically, we just pound on it in testnet. So there have been a bunch of tests that people have been writing. So with those tests, we pound on it in testnet, and if it passes muster during that phase, then we roll it out to we roll it out to mainnet.
That's
so
great.
we're quite confident that it will be before the end of the year when it goes out to mainnet.
That's really soon. And I know that another functionality you were working on concurrently is the block merge. Can you talk about what are the benefits of block merge? How does that also help with the scalability and growing the network?
Yeah, so what block merge does is it gives you a DAG instead of a chain, because it means that when you have two blocks coming in and they both want to build on some base state, the question is, can you check whether or not it's safe for both of them to build without having to rerun all the computations in both blocks? And it turns out that because of the way Rolang works, we don't have to, like in the worst case scenario, you'd have to go, well, if I run block 1 and then block 2, is that the same as if I run block 2 and then block 1? Right? And so that's actually increasing the total amount of computation that you have to do. And it's just much better just pick an order and stack them one on top of the other. But because of the way Rolang works, we can check the Rolang syntactically, and we can detect whether or not there's any conflict. And we can do it in a very, very low complexity, right? So it can be done blazingly fast. And because it can be done blazingly fast, that means that we can figure out very rapidly those situations where you can just have the two blocks build side by side on top of the base state. If that makes sense. And so what that does, it means all of those transactions can be run at the same time, as opposed to first I run these and then I run these. Yeah. So instead of end on end, they're now running at the same time, which means you get much more throughput in the network.
That's really interesting. And for those that most aren't familiar, the Rolang is the underlying programming language that you've developed to help run RChain. And a lot of people also aren't familiar with the difference between blockchain and DAG, direct acyclical graph, which is a little bit different than a blockchain. But normally in a traditional blockchain like Bitcoin, there can be only one block at once, and if they two happen at the same time, then one of them doesn't get validated and it gets deleted essentially. So is that now with the DAG that RChain's running, there can be multiple blocks, and it doesn't really matter which way they go in because it will figure itself out?
That's essentially what's going on. That's right. So what happens is we'll detect if there's any conflict. And if there is a conflict, then one of them gets booted. We'll say, sorry, try again. But if there's no conflict, then they can go at the same time.
Mm-hmm.
Yep. So which is again, if you think about it, what's the likelihood that someone buying empanadas in Chile, their transactions are going to impact or somehow interfere with someone buying grilled tofu from a street vendor in Shanghai?
Mm-hmm.
It's near zero. Yeah. Right. And in fact, that's the reason that our existing financial network scales, is because most of the transactions are happening in parallel.
Mm-hmm.
You want an architecture that provides that.
Totally. Now I want to jump into real world applications and solutions and the potential for RChain to grow into the real world. Now, since we last spoke, it was around the time before the pandemic happened and COVID-19, and there's been a lot of blockchain companies that have come out and said, hey, our solutions can solve real world problems even in this pandemic right now. And I'm curious to hear how RChain has been affected by these problems, and if you've been working with any companies to provide solutions in the real world right now.
Yeah, actually, so there are two solutions that we've been looking at. One we rolled out for our general membership. So rather than have a face-to-face meeting during COVID, we had at a distance meeting, and the vote that happens each year annually that elects the board and addresses items of business was all done through a DApp called Our Vote 2020. And Our Vote 2020 is an on-chain voting application that actually anybody can use. So any community whatsoever, any organization could pick up this DApp right now, and all you have to do is to have some kind of correspondence between voter IDs and a rev address. However you get that set up, that's for you to decide how that's done. But as long as you have some correspondence between legitimate voters and a rev address, then the rest of it is, and then you can add issues to be voted on. Mm-hmm. So you have an issues list or a vote list, a ballot, and the membership in terms of rev addresses, and then the system takes care of it from that point on. Mm-hmm. And so we built it as a generic application, and then we put in the issues. The secretary for the co-op put in the issues and the member list, and then the members used Our Vote 2020 to vote on the board and some significant items of business. So that we felt was very timely, considering all the questions about U.S. election.
Yeah.
Here we can cryptographically prove that it's secure. There would be no question of fraud.
That's amazing. Yeah.
So we felt, and the thing that's most exciting about it is it took just a few weeks, and it was done by the community. So it's all open source. You can look at it. The people that did it were very proud. So they were able to show how do you know that the application is doing what we claim it does. So they're able to. There's a nice little demonstration of how you, as a user, can check that the ballot that's being prepared is in fact how you voted. Mm-hmm.
That's really interesting.
I felt that was really amazing, right? This is what we're trying to say, is that RChain is all about self-organization. Mm-hmm. Right? The community self-organized and got their own voting mechanism together.
Yeah, and I didn't know that you can use it, right now for anything. Like, that the U.S. could have picked it up and started using it for as long as everybody in the U.S. has a rev address. They could start
that's exactly right.
using it for the election. So yeah, very timely, and it's interesting to hear that it's using your own blockchain for your own AGM successfully in a democratic way. That's really interesting. Now, we're running out. I
know we're running out of time, but if you don't mind, I just want to mention really quick.
Definitely.
We also have been approached by some folks who are interested in a COVID wallet. So this would be an on-chain application that allows you to record test results and vaccination results. And we put together a design, and then community members came together and have implemented a good portion of the design. And then we walked that design past some physicians who effectively validated the design, and now want us to talk to other physicians. So we're also very excited about that.
Definitely, yeah. Two of, I would say, the top priority problems right now to solve in America. It sounds like you're right on top of them with the RChain project right now.
Yeah, that's the idea, and again, it's done by the community. Right? It doesn't require like super rocket scientists, right? It's the way to think about RChain at this stage is think about the World Wide Web in the mid '90s, where suddenly people were going, well, I could make a website.
Yeah,
I can do that, right?
Yeah.
So it's the same thing with RChain. RChain now gives this new layer of distributed, decentralized technology where anyone can kind of look at it and go, well, I could make a dApp.
Definitely. And now, as you said, anybody can make a dApp. You have an open co-op that anybody can join. Anybody can start working on RChain. For those viewers that are interested in helping with these problems that you're focusing on right now, and many more, I'm sure, what's the best way for them to learn more and to get involved?
So yeah, first and foremost, RChain.co-op. Go to the website. It's only $20 to become a member. Once you are a member, then you can join our Discord channel as a member and have full access to all the membership information. Every Wednesday, we run a Zoom meeting for people to get a debrief. And if you're a member, there's also a Friday closed door session that is members only. So those are the biggest. There's also the RChain blog on Medium. So check that out as well.
Great. I will leave all those links in the description box below. Greg, thanks so much for the time and the update, and all the best on RChain. I'm sure we'll speak again in 2021, but it sounds like you're on the way to finishing this last finalized state. And then once that's done and we're into the new year, let's follow up again in the near future.
Perfect. Thank you so much, Ashton. You have a good one.